Hello, this video is to take you all through the key features of Informatica Test Data Management with the help of a hands-on demo. Before I start, let's spend a few moments on what Informatica Test Data Management is. So, TDM is used to secure and mask the data that is being brought from production into the QA or dev environments for testing and development purposes. It does the masking in stream with no staging layer required in between. The masking rules are all inbuilt, so it's more of a plug and play kind of a solution. Well, of course, custom masking rules can also be configured very easily. It also has inbuilt data discovery intelligence, which can automatically find the sensitive data in your database and mask it. Data subsetting can be used when not the whole production dataset, but a small subset of the same has to be moved for dev or QA requirements. It maintains a referential integrity in place while doing it. Lastly, it can also generate synthetic data directly in your dev or QA environments if production dataset is not available to be masked for that particular table. So TDM basically deals with these. So we have data masking, your data subsetting, and you also have synthetic data discovery, synthetic data creation along with the data discovery part. So what are we going to see in this demo? We are going to see intelligent data discovery, in-stream masking, in-place masking, data subsetting, and test data generation. So with this, let's jump into the demo and see all these concepts in action.
This is the Informatica Test Data Manager UI. So once you open the Informatica Test Data Manager, you will be able to see this kind of a dashboard, which tells you the risk across the different projects that you have in your enterprise. So it's a consolidated place where you can monitor the sensitive attributes and the risk of sensitive attributes in your enterprise. Okay. So as you know, Informatica Test Data Manager has inbuilt PCI, PHI, and PII policy. Okay. So based on these policies, Informatica Test Data Manager can intelligently profile your database and automatically tell you where your sensitive data is. So if I go and just click on the PCI policy, you will be able to see the data domains or the sensitive attributes which are connected to the PCI policy. For example, this particular policy will check for account number, birth date, credit card, etc. in your database, right? So if you go and open a credit card domain, you will be able to see the data pattern or metadata pattern. So as you know, Informatica Test Data Manager, when it does this intelligent data profiling, it does it at two levels. It does at the data level. Okay, so for example, there is a credit card column in your table. It will go and actually see the data inside the column, okay, and find out if that belongs to a credit card domain, right? So to do that, it uses this kind of a regex pattern to find out if that particular data belongs to the credit card domain, and also it will go and search the metadata. That's the column name, okay? So you'll try and find out if these kind of attributes like credit or CRDT or CR is present in your credit card column name. Okay. Based on that, the rule will be automatically applied to this credit card domain. So if you want to see the rule which is applicable with the credit card domain, you just have to go and click the rule here. You'll find out the rule which is already linked to this particular domain. Here you can see the properties of the rule, right? So this particular domain is using the Informatica credit card masking technique, which is already inbuilt. Okay. In similar patterns, you can go and check the PHI and the PII policies. So in the PII policy, for example, you will have all these data domains which comes out of the box, against which the profiling will be done, and you'll be able to find out sensitive data in your database automatically. Having said that, let me actually go and show you how data masking is done. Okay. So what I'm going to do is, I have this Oracle schema, right? So the use case is, I want to mask the customer data in my loyalty source schema. Okay. So if I go to loyalty source schema, This is the data that I have in my customer table in my loyalty source schema. So the use case is I want to mask this customer data from my loyalty source schema and push it into my QA environment, which for my case is a loyalty target schema. Okay. So if you go and see in the loyalty target, there will be a customer table which will have no data. Right? So what can I do essentially in test data management to solve this use case? So I go to a test data manager UI and I have to create a new project for this. Okay, so I go to actions and new, and I say a new project name, mask, customer demo. Now this project has been created. Inside this project, I need to import the data sources applicable for masking, right? I can import data sources from here. You can import it from a Power Center repository or from a database connection. I'm going to use a database connection. Okay. And for my use case, I'll just bring the customer table to keep things simple. Right, so this will import the customer metadata from my source schema into the TDM repository. Let's just wait for some time for the input to be completed. Okay, so now my customer table has been imported into my particular project. The next thing is for intelligent data discovery, I need to add policies to this project. Okay, so for the sake of example, I will add the PCI policy. So essentially, this policy will run against the customer table in my source schema and intelligently try to figure out what are the sensitive attributes in the customer table that needs to be masked. Okay, so I can just voice assignment is done. Next is the discover thing. So discover is actually the place where we will run profiling against my customer table in my source schema and try to find out what are the sensitive columns. Okay, so go to profile and I create a new profile. I want a profile for primary key and data domain. I want to run the PCI policy pack, and I want to run data discovery on the data and the column name. Okay. Okay. So my profiling, creation of profiling is set. Okay. Just go to my profiling. Okay, so I use the resource connection. Go to monitor and see the job status. So my profile sensitive customer is running. Okay, now that it has succeeded, we'll go and check out the results. So I will discover file, go data domain, see the results. Okay, so it has automatically found out that there are 4 columns in my customer table that matches the last name, first name, credit card, and birth date domain inside my PCI policy. Okay, now I'm just going to approve whatever test data management has found for me. Okay, so essentially my data domain classification is complete. So automatically the solution found out what are the sensitive data or what are the sensitive columns in my customer table, and once that intelligence is being presented by TDM, I'm approving it and we're good to go. The next part is we need to define a data masking plan here. Okay, so I go to data masking and then I say, and inside data masking, we can see the customer table, okay, with all the columns for that particular customer table. Now, the columns that I have marked using the data domain as sensitive columns will have an attribute sensitivity of yes, okay. So I need to run a filter on sensitivity. So all the sensitive columns are sorted and we can see it at the top together, okay. Now the use case is we need to mask these sensitive columns before the customer table is being sent to the development or QA environment. Okay. What I do here is, all I have to do is I have to assign the policy pack, okay, and since it's last name, I assign the last name rule, okay. Similarly for all the 4, do it also. Okay, true this. So my rule assignment is now complete. So essentially what I did is, I just, added the corresponding rule for last name column to with the associated last name rule. That's it. So I did not create any rule. All of the rules were already inbuilt in test data management. All I did was to just click here and assign the rules and approved it. That's all. Now I need to execute what I have done. So I need to create a plan for execution. So I'll go to new and I create a plan. I'll add the masking component. There's no subset component here, no generation component here. Okay. So these are the 4 columns that are supposed to be masked. So I just say yes to all of them, right? This is where I give the source and target connection, right? So my source connection is a loyalty source schema, loyalty source connection, and my target connection will be the loyalty target schema, right? So that is my dev or QA environment for this use case. I'm going to use a loyalty target connection. If you wish, you can use the truncate table, disable indexes and disable constraints in your target before you load the target. Okay, so let's just use it. And you can have your update strategy here. Since this is in-stream masking and the target is empty, I'm just going to treat the source closure as insert, and any updates if required as update. Next. So one major thing here is in-stream masking is when you are trying to take data from one schema, let's say the production environment, and then putting it into another database. Let's assume the dev or QA environment, right? So it will take the data from your source database, do the masking in-stream in the Informatica server, and then push it into the target database. Okay, so we are not staging it anywhere. It's all in-stream. You can also do in-place masking. So for example, you want to mask the customer table in the loyalty source schema itself. So you've already bought the data from your production into your QA. It's already there, but now you want to mask the data inside your QA, right? So that is the example of in-place masking. So in that kind of a use case, obviously your source and target is the same, right? So your source connection and your target connection will be the same. So in that kind of a use case, we just have to click this, use source connection as target connection. That's it. So since we are doing in-stream, we'll have different connections for source and target. So let me go ahead and do next. So my customer table, that's fine. So now my plan is created. Okay. The next step is to create a workflow for this particular plan, right? So I'll go and then say generate workflow. Workflow now. As usual, I can go to my monitor and I can see the status of my workflow creation. Okay, so now my workflow creation is succeeded. The next step is to actually go and execute the workflow. Okay, so I go to execute, go to my plan. In my plan, I can see the workflow that has been created right now. Right? All I have to do now is go and execute it. So I go to action, execute workflow. And then I can go to the monitor screen and see the progress of the workflow. Okay. So remember, initially my customer table in my loyalty target schema had no data. That is what I showed you before starting with the demo. Now the expected output is the customer data will be taken from my production database, that is my loyalty source schema, and then that particular data will be pushed into my target database or the dev or QA environment. For my use case, it is a loyalty target schema, right? And the sensitive attributes that has been found out automatically, that is credit card, date of birth, first name and last name, should be masked in stream. So that data should not be the same as the data that is there in the customer table in loyalty source schema. In my use case, the production schema. So let's wait for the workflow to done, and after the execution is done, we can go and see the results. Right, so now the workflow has succeeded. So let's go to my loyalty target. So initially there was no data, right? Let's just again run this query. So now I find that my loyalty target or my dev and QA database has the customer data that I wanted, but is it masked? So let's see. So let's just take the customer ID of 444. Select customer. Okay, so in my source database, the last name is Browning, the first name is Meena, the credit card number, the last four digits are 4456, and the date of birth is 30th June 34. Okay, so now let's go and see what is the data for the same customer ID in my target. So if you see, the data has now changed, right? So from Meena Browning is now Chi, the first name and the last name. The credit card number from 4456 is now 2297. And essentially the date of birth has also been masked. It was 30th June here and 15th April here. So the four sensitive attributes that are found out automatically, that was the first name, last name, credit card number and the date of birth, has been successfully masked in your development or QA environment, right? This was the first use case of in-stream masking. The second thing that I want to talk about is, it's good that we have all these PCI, PHI, and PII policy out of the box, and each of these policy pack have a lot of data domains which can be used to automatically profile and find out the sensitive data in your target or in your source databases. Okay, but what if there is some rules or some column names which are not present in this PCI, PHI, and PII policy pack, but you need to create a data domain for that because for your kind of business line, that particular column is a sensitive attribute. Okay, in that case, using Informatica Test Data Manager, you can easily create your new data domains, and then using those data domains, you can run profiling. Okay, so to explain this use case, again, I have taken a very simple example. I want to mask PAN card, okay, because in the Indian banking context, PAN card is a very sensitive attribute that needs to be masked. Okay, now for PAN card, we do not have an out-of-the-box rule, and it is not included in the PCI policy pack. Okay, so nothing to worry. I've created a PAN card data domain, and I'll show you what I've created. Okay, so this is a PAN card data domain that I created manually. I go here. For this data domain, the data pattern that I have suggested is this. Okay, so what it will go and find out is, it will see if the first 5 characters in your PAN card number, if they are characters. Okay, the next 4 should be digit, and the last should again be a character. If the data matches this kind of a pattern, then it should be a PAN card. Okay, similarly for the metadata pattern, what I'm trying to say is, anything which has the word PAN as a in the column name should be taken as a PAN card data domain and should be flagged to me as a sensitive column. Okay, so now the thing is, both of this is editable, and based on your requirement you can change it. And the preferred rule is the PAN card rule that I have connected to this particular data domain. Again, I have created this rule. Very simple to create this rule. It's a key rule, and what I have told in this rule is, I'm trying to tell is this. So what I'm trying to tell is, only a digit part of your PAN card should be masked, okay, and do not go and touch the alphabet part of the PAN card. Okay? This is the rule that I created. Rule in action now, and I have created a very simple table in my source schema called customer PAN. So it essentially has 4 customer names and their associated PAN cards. Now I want to use my PAN card rule which I created in TDM and I want to mask it. And this time I'm going to show you in place masking. So I'm actually going to update the same table, the customer PAN table in my loyalty source schema itself. And the PAN card should be masked with the updated values. Okay. So for the sake of comparing later, I just put one value of the name and PAN card here. With this, let me go back to TDM and let me show you how I can use the custom PAN card rule which I created. So again, as usual, I have to create a new project. Import the data source. I'm going to import the customer PAN table for this use case. Now I'm going to add the PAN card rule into my PAN card masking project. So I can see the attributes of the rule here. I have to again create a new profiling rule. Now that it has succeeded, I'll go and actually check the results of the profiling. As in the earlier case, my new PAN card data domain that I have created automatically finds out the PAN card number in my customer PAN table. So I need to just approve this. Data masking. So PAN card is sensitive based on the domain that I created. I just have to assign the rule, so it gets automatically assigned. Next step is to create the plan, as in the earlier case. So action. There is no subset and no generation component in this particular plan. Since I'm doing in-place masking here, I'm going to use the same. I'm going to use the source connection as my target connection. Okay, and obviously my source rows will be treated as update. So the existing source rows in my customer PAN table will be updated with the new masked value of PAN. Now this plan needs to be executed, so I can just generate and execute in a single step. I can monitor monitoring PAN. So as it is running, there are two important points that I want to reiterate. The first is, if you remember the first use case of in-stream masking, we did intelligent data discovery, and based on that, none of the masking rules had to be actually written. All of the data domains in the packs had masking rules associated with it. All we did was assign that rule and run that workflow, and my masking was complete. So everything out of the box. In this case, I created a global data domain for PAN card. Again, this data domain can be reused across any number of projects in your enterprise. And again, all I did was assign that rule to that particular column, and the masking is done. And another important thing that you will notice here is the nature of the masking attribute remains the same even after you mask it using Informatica Test Data Management. In a sense, a first name like let's say for example James, right, or Shovik, will not be masked into a gibberish set of alphanumeric values like AX, B, Z, Y, Z, or any set of alphanumeric values which alphabetical values which do not make sense. A first name gets masked with a logical first name itself. Okay. Similarly, the credit card that we saw in the previous example of in-stream masking, the credit card got masked with another valid credit card number. It was not just a combination of 16 numeric characters brought together to form a credit card. So that is one important aspect of the masking solution, that the attributes that you're masking, the nature of the attribute remains the same data-wise even after you run the masking rules. Okay. So now, since this workflow has succeeded, let's go and check the result. So initially, before I had run this masking plan, my PAN card in my customer PAN for Shovik was this. So essentially now, since this is in place masking, Shovik should have been updated in this customer PAN table with a new PAN card. Right, so let's run. Essentially, the PAN card has now been masked. The new PAN card is this, right? So this essentially brings to a close the use case of in-place masking and also the use case of creating custom rules or custom data domains and then using it in projects to mask. Next thing which I want to show is data subsetting, right? So what is data subsetting? Data subsetting, as you know, is a set of tables that you want to put in your dev or QA environment from your production, but then you do not want to bring the entire content of the table from your production to dev or QA, because for testing that particular piece of code that you have created, you only need a subset of the table, right? So it does not make sense to actually go into your production environment and get or create the entire production data set from production to your dev and QA. Okay, so now the data subsetting use case that I'm going to create is this. Again, like my in-stream masking use case, I want to subset the customer table, right? And I want to bring it to my loyalty target schema. But I do not want to bring the entire customer table. I just want to bring customer attribute customer rows which belong to India, right? So if I go and do select star from customer, you see there's a column for nationality, which has a lot of countries listed like Argentina, Canada, France, India. So now my development team has created a new piece of code which only affects customers that belong to India. So essentially, I just want to bring the Indian customers from my production database to my DevQ environment. But now the trick here is this. I do not know as of now how my customer table is connected to the other tables in this particular schema, right? So there may be primary key, foreign key relationship between customer and other tables in this schema, right? Now, when you do a subset, it is very important that the referential integrity of that particular table remains intact, right? So in this use case, I need to create or run an entity profiling, find out how customer table is related to other tables in a particular schema, and once that relation has been found out, I have to take that entity as a whole and then take it and push it to the target database. So not just the customer, but customer and its associated child tables, right? So with this in our mind, let's go to the TDM. Okay, so now to do the subsetting, I need to create a project again. Now, since I do not know how the customer table is connected to other tables in my schema, for the setting part, I actually need to import the entire metadata. So I go ahead and do the same. I'm actually going to import all the tables in my schema into the TDM repository. Now, since my profile has succeeded, I actually go and see the entities that TDM has automatically created for me. So TDM has profiled my database and found out 5 entities. Okay. Since the use case now is to subset customer, I'll be interested to see the entity that is related to customer. So if I go and click here, I will be able to see the table relationship that customer has with other tables in that particular schema. Okay, so I can see that customer is connected to address using the customer ID. Similarly, it is connected to ticket coupon, connected to statement line, connected to ticket. Okay, you see the relationship type here, the confirmation percentage here. Okay, so now what I have to do is see the constraints that has been presented by TDM and then approve them as usual. So I approve the first four because I do not want to create two constraints between two similar tables, customer and ticket. So I already have a customer ID constraint. I don't want to create another constraint on ID now to reduce redundancy. Okay. Approved. I go into the customer. Fine. So my entity creation is completed. The next step, as usual, is I'm going to define, see my profile entity customer already here. Here, here I can see in a diagrammatical representation of the customer entity. So my customer table is my driving table and it is connected to 4 child tables. Okay. Now I will create the subset criteria or subset filter condition on customer right here. So I'll just do edit criteria. And as I said, I wanted to subset based on nationality. Nationality. And once you do your, once you set your subset criteria, you'll get a small symbol here which says that a filter criteria has been created in your driving table. Okay, it's done. I need to create a plan as in the earlier cases. There is no masking now, but there is a subset component in this use case. Generation. Right. So nationality equals Indian is the criteria that I had set, and you can see it here. These are the 5 tables that will be read from my loyalty source schema. It will be subsetted based on the driving table customer and the attribute which says customer data only belonging. We just need customer data that belongs to the nationality of India. Okay, and based on that, all the child tables should also be subsetted. Okay, now that I have succeeded, let's go and see the results. So now in my target schema, that is loyalty target, essentially I should only have customer that belong to the nationality India. Sorry. And this is all I have. So the customer table has been successfully subsetted. I only have the subset of the data that belongs to Indian customers, right? So now the second thing that we need to check is that the four child tables, namely ticket, address, statement line, should also just have customer IDs that belong to this customer data set, right? So now for this, let me just go and check the entity again. Address, statement line, ticket, and ticket coupon. These are the four child tables which should have been subsetted also like customer or in relationship to customer. So this query actually proves that only the customer IDs that belong to the customer table in my target schema, only those customer IDs are present in my address table. So essentially, along with the customer table, my child table, which is address, also got subsetted. So the referential integrity, the RI check is in place, right? Similarly, I can do it for some other table also. Let's do it for ticket. Okay. Again, the query is not fetching me any results. Essentially means that all the customer ID in ticket is similar to the customer ID that is present in the customer table, and there are no extra customer ID in ticket. So this is where I end subsetting. So we successfully subsetted customer from my source, that is loyalty schema. I just brought customer data, which belongs to the nationality of India, and along with it, all the four child tables of ticket, address, statement line, and ticket coupon also got subsetted in a way that the customer IDs that are present in the subsetted customer table in the target, only those customer IDs are present in the four child tables also. So as an entity, the entire entity is subsetted, and the referential integrity is in place even in your target schema or your QA or dev environment. Okay. This brings me to the last use case that I want to talk about today, and that is test data generation. So there may be a lot of times in which you have created a new column in your dev or QA environment, right? You've created a code for a new column, or you've created a code for a new table itself, right? And you need to test that particular new piece of code that you have created. So essentially, since this is a new table or a new column in a new table, there is no data available in the production environment. So in this kind of a use case, you will require assistance to synthetically create data in your dev and QA environment so that you can run your you can test a new piece of code against that data that you have synthetically created. So that is the use case of test data generation, and I'm going to show you how we can do it using Informatica Test Data Manager. So again, I've created a simple table in my source schema called customer gen. Okay, so let me first truncate this so that So this is a table that I have in my source schema, which has essentially four columns: customer ID, customer name, credit card, and phone. Now this particular table has no data, and I want to synthetically create data for this particular table, right? And the data should be such that it makes sense. So a name should have a data which looks like a name, a credit card should have data like looks like a credit card, and the same for the other two columns, okay? So how do I actually go ahead and do it using Informatica Test Data Manager? I've already created a project for this. Instead of creating a new one, I'll just show the project that I've created and I explain it using that. Okay. So inside the customer data generation project that I've created, I've actually created 4 data generation rules, okay, pertaining to the 4 columns which were there in my customer gen table in the source schema, right? So what are the rules? If you see the customer ID rule that I've created is this. So essentially what it will do is it will append ID as the first 2 characters of the customer ID, and then it will create 4 random digits, okay? Similarly, for phone number, append 98 as the initial first 2 digits, and then we'll create a random set of 8 digits, okay? For credit card, a similar regex is what I've created, okay? And same is the case for names. So for names, it will take the data directly from the dictionaries that TDM has, okay? So these 4 rules has been added in the customer data generation project, okay? Now, I've created Okay, I created the data generation here in the define. So this is the table, the customer gen table. Okay, the credit card has been appended with the credit card generation rule, the customer name with the name generation rule, and similarly for the other 2 columns also. Okay, based on that, I have created a plan. Okay, a plan customer generation, right? And now this has the generation component here, the customer gen table. All I have to do now is to just run this. So if you remember, I've truncated the table and now it has no data. Let me run the customer generation plan from TDM. So as the plan is running, the use cases that I showed you here are for small tables, right? The customer table and then the customer pan table and stuff like that. And this is basically to keep the demo very simple so that everybody can understand it and then use it as and when required. Okay, but then if you want to do this at a scale, okay, the entire process remains the same and it remains as easy as it is right now. So for example, in the very first use case of customer in-stream masking where I mask the customer data, if you want to mask the entire schema, suppose you have 100 tables in the schema and you want to mask all of them at one go, all you have to do is just import all the tables at one go instead of just one table that I showed, right? And then run the intelligent profiling across all the 100 tables. Once intelligent profiling is done, you will be able to see the sensitive data across all the 100 tables. Just assign the rules which are already inbuilt, and then run that workflow. So automatically all your 100 tables will be taken to production and then pushed into QA and Dev with the in-stream masking in place. So the process, even at scale, remains the same and it remains as easy as it is. to what I'm showing right now. Okay, so having said this, the plan for customer generation is already succeeded. So now let us go to Oracle and see what kind of data this thing has created. So if you see, data has been synthetically created using TDM. So customer IDs, we have created random customer IDs. Customer name, as I said, is not just a set of alphabets to create gibberish, because they are actually names that make sense. Okay, credit card number is again credit card numbers that make sense, and similarly for phone. Okay, so just to end my demo, what I showed today was customer in-stream masking, intelligent data profiling, then customer in-place masking, how you can easily create custom rules and customer data domains as global data domains and then run it against your database to mask them. I showed you how you can easily subset data, how you can easily create entities from the TDM GUI layer itself. And even if the primary keys and foreign keys are not specified at the database level in your tables in the source schema, Informatica Test Data Management can actually profile and suggest you primary key foreign key relationships, and you can create logical keys from the Informatica TDM GUI itself. Okay, so in my customer data subsetting use case, there was actually just one physical primary key foreign key relationship in the database, and all the rest of the three that I showed or that TDM found out was logical data keys which I created in the TDM GUI. Okay, and going forward, you can also create test data using TDM. So it has test data generation facilities. As and when you have tables or you have columns in tables which has no data in production, you can use the test data generation facility of TDM to synthetically create meaningful data. With this, the demo comes to an end. Thank you.